So if you see the pause symbol and there's a few in this presentation, pause, go on to the next part of the presentation. Take any notes before you go on to the next part of the presentation. But today's objective, the student will be able to solve for a variable with addition and subtraction. This will be done through a presentation and classroom activity. You guys have to pay close attention. There is a lot to this. I try to make it easy and throw something out at the beginning that kind of catches you to the topic to try to draw some sort of interest, because this can be boring. It's not like it's something like right now it's easy and then it gets harder and harder and harder and harder and harder. But first I want you to think of the Ganofa hawks. Blech. Remember the Ganofa hawk. Remember, Ganofa hawks are evil. It can never happen. So still no Ganofa hawks, but if the Ganofa hawk was real, we're going to put him on our balanced little scale. We have our equal sign in the middle because you see the equal, but the Ganofa hawk. There's one Ganofa hawk on the left side, and he weighs down the scale. So what we must do is we have to put something else equal to the other side. So two Ganofa hawks are equal to each other. So the Ganofa hawk scale goes back to balance. Now, the arch enemy of the Ganofa hawk, the Alahawk or the Gator hawk or the Gator bird or the Alabird or the whatever it is, takes away one. It's not balanced anymore, so it goes back down. So we have to take that Ganofa hawk off to make it balanced again. With all this weird rambling about Ganofa hawks, all you need to know is if you put something in one side, something has to go to the other. Either remove, take away, add. So if you add a positive to the one side, it's going to kind of go blink, 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 and fall down again. So to make it equal, if we have a positive on one side, we have to have a negative on the other. And this will make more sense in a minute, but so we're going to throw a negative on this side. So it will actually equal out our scale. And I'll show you guys how this works in a minute, but now that we have a positive on one side and negative on the other, our scales are not equal. Hooray! So let's throw a positive back on that left side, but this time it's going to be a positive 5. So if we have a positive 5 on this side of the scale, what we need to do on the other side of the scale is we need to put a negative 5 into the other side of the scale. So the scale will be negative. Here comes the 5. Where are you, Mr. 5? It's coming in. There's the 5. And now the scale will balance. So that's pretty good. Well, how will I apply this? How will I apply this? You're going to find out in 1 second. Before we figure out how to apply it, we have to go then and give it a second. 5 plus x equals 7. So if we have 5 plus x equals 7, we have to get x by itself. So before all this negative one side positive, x has to be alone. X it doesn't like being, it's a loner. So to get loner, we have the x by itself. We're going to have to do something to the 5. So let me get rid of that circle. So first thing we're going to do is we're going to write an equal sign right below it. Then after we write this equal sign, in a second it's going to pop up. Now think of opposite, what we just did with the Ganofa hawks. So now that we're thinking about that opposite, it's going to come back up in a second. Where is it? Okay, that 5 that's circled. We have to get that 5 to the other side. So we said if there's a positive 5 on the one side, we have to put a negative 5 on the other side. So we have to put a negative 5 over here because we want to put a negative 5 on the other side of the scale. Since there's a positive on the left side, we got to do a negative on the right. So now what we're going to do is we are going to actually start canceling and subtracting. So 5 minus 5 is 0. So in a second, I'm going to cancel it, cross that out. And then the 7 minus 5 equals 2. So that's basically done right over there. What we have to do now is we have to drop down this x. So x equals 2. So now we're basically done. This problem's done. It seems a little bit harder when we get more steps, and it does get kind of harder. But so what we do, most teachers are going to require you to box your answer or circle your answer, do something to your answer to show it's done. But this is done. This is solved. This is our answer, x equals negative 2. So we're not done yet. In a second, some more words are going to pop up, so let me wait for it to catch up. As I said, however, we're not done yet. I just said we're not done yet because we have to check our answer. So to check our answer, what we're going to do, we're going to then take that x equals 2. So I brought it back to our original problem. So if we have x equals 2, I'm going to go and kind of line up those x's. So those x's are the same because that's how they are. So x equals 2. So we're going to take that 2. We're going to substitute it in for that x. So when we substitute in for the x, we have a new problem that says 5 plus 2 equals 7. So let's sign 5 plus 2. Yeah, 5 plus 2, 5, 6, 7. So 7 equals 7. This problem checks. It's good to go. That's called a check. We prove that our answer is right and we're done. Most teachers will have you check your answer. So that's what they're meaning. Check. Put it back in. So if the problem doesn't check, redo the problem. We do the two problems, not this problem, the next problem after we redo it. But right now, you guys need to go look at this, and if you didn't understand this, go back to rewatch it, because here's your pause slide. If you didn't, wait and go on to the next part of the presentation, where we're now going to do the other side, the subtraction. So we have our x. We have to get it alone. So to get our x alone, what we need to do is that 3, that negative 3, we have to get rid of it. So again, we said negative. The opposite of a negative is a positive. So we put a positive 3 on this side because we want to get a positive 3 to the other side. So now our 3's are going to cancel on the left side. I don't know, see, cross them out, they cancel. So negative 2 plus 3, so if you have negative $2, like you owe your parents 2, and you have $3, so you give them back the 2 you owe them, you still have $1. So we have a positive 1 as our answer. So with that then, what we have to do is then we have to drop down our x, because it's still there. So our answer is basically done. X equals negative 1. So with our x equaling negative 1, we're done. In a second, it's going to all go back together, and we are going to have, see, this is our answer, x equals negative 1. Sorry, x equals 1. I don't know if I said negative 1. Either way, x equals 1. However, we are still not done. Remember about that thing I said a minute ago? We have to check the answer. So check the answer. We rewrite our whole problem over again. We rewrite what our answer is going to be. We're going to take that x, because the x's are actually the same. We're going to put that 1 in for x. So in a second, 1 minus 3 equals negative 2. Let's find out. So when we read our problem, 1 minus 3 is actually negative 2. So negative 2 equals negative 2. So yep, this one checked also. So in a second, I'm going to give you guys a chance again to go back, because we did the addition part first. This is the subtraction. All it is opposite. Remember, opposite. If we have a positive on one side of the scale, we have to go to negative on the other. But if you need to pause to go back and take your notes. So in a second, it's going to come up. Here's a problem. They already worked it out for you. So we are doing the work, la-di-da-di-da, cancel. So we have negative x equals 2. So you can run into this, and then you're like, okay, so I have negative x equals 2. Let's plug this into the problem, because Mr. Beuthin said check it. So let's check it. Wait. So we put that negative x, we put the 2 in there. So 2 minus 2 equals 0. Wait, 0 doesn't equal 4. That doesn't check out. Well, this is why Mr. Beuthin had you do those little checks, because you're going to find out that it didn't work out. So we did something wrong in the problem. It's because that negative sign is evil. Yes, it's evil. So anytime you just can't do it. It's something you can't have a negative x. So anytime you have a negative x, you change the sign of everything else on the other side. So let's first change the x to a positive. And then we're going to go to the other side of the equal sign, and we're going to change every sign in there. So since we only have one sign over here to change, we just go and make that sign a negative. That's all you do. You're actually multiplying by a negative 1, but let's just you're changing the sign. Makes it a lot easier. So let's redo our work. We're going to put that negative in there. We're going to go down the line and wait, Mr. Beuthin, negative 2 minus a minus 2. Yes, remember, minus a minus 2, or minus a minus equals a plus. So we can put that in there. So if we go all the way down, 2 plus 2 is 4. So therefore 4 equals 4. This problem also checks out. Awesome. We got another one. So that's it. So we're going to have to do our check for understanding in a minute. So if you need to go back and take any notes, go back and take some notes. If not, go on to the next part of the presentation, which is our check for understanding. So here's a few problems. Take a few minutes, do it. There is probably the second one, the negative r plus 3 equals 4 is what most people are going to get wrong. So if you get that one wrong, it's what we just did because it's a negative variable. But go through it. I'm going to stop talking. When you're done with your problems, unpause it for the answers. So here you guys go. Here's the answers. Like I said, you probably got that second one wrong because you had to change all the numbers inside there. So we'll go more in depth later about when we're doing the class activity part, about why we changed the R for like that one, why it happens, and all the fanciness that goes along with this. But hopefully you got them all right. So to recap, variables, you still can't, you're going to know if a Hawks comes later with combining like terms, but think about that scale. If we have a positive on the left side of the scale, we have to put a negative on the right side of the scale. We have to always have it equal. So if we're doing something to the one side, we must do something to the other. So if we have a positive 5 plus x equals something, we want to get that x alone. So to move that positive to the other side, if it's a positive 5 on the one side, it has to be a negative 5 on the other side. So this is one of those things that it gets easier as you do it over and over and over. We're going to take it step by step, but this is the first part. The objective is the student will be able to solve for variables with addition and subtraction. This will be done through a presentation and classroom activity. So hopefully I didn't bore you guys too much. This one is a little bit longer for a reason. Next, we're actually going to do multiplication, and then we're going to do multi-step. So please understand this one before we start going to the next few. But good luck with this one, you guys, and have a good evening, and sorry this one was so long.